In this video, we are going to demonstrate what is starch and how the starch is hydrolyzed by acids. As we all know, starch is a carbohydrate. We take carbohydrates mainly in the form of starch. Starch is formed of two components, amylose and amylopectin. So this is starch solution. So starch is insoluble in water. We can see it is turbid. So this solution is after settling for some time. So the soluble component is amylose. The insoluble component is amylopectin. We will perform the test to prove that starch is a carbohydrate, polysaccharide and a non-reducing. This is a test for carbohydrate. For Molish test, we have to take 1 ml of the starch solution, 2 drops of Molish reagent and 2 ml of concentrated sulfuric acid. Appearance of reddish violet ring indicates the carbohydrate's presence. This shows starch is a carbohydrate. Iodine test is a test to identify polysaccharide. For iodine test, we need to take 2 ml of the starch solution and 2 drops of the iodine reagent. It will form blue color. The presence of blue color indicates the presence of polysaccharide starch. Benedict's test is a test to identify reducing sugar. For Benedict's test, we will take 3 ml of the Benedict's reagent and 5 drops of the starch solution and we'll keep in the boiling water bath for 2 minutes. It is blue in color. If starch is a non-reducing carbohydrate, so the blue color persists. After 2 minutes, we can see there is no color change. In the Benedict's, the blue color remains the same. This indicates starch is a non-reducing carbohydrate. So far we did the test for starch. Now we are going to do the starch hydrolysis. The starch solution is hydrolyzed by adding hydrochloric acid. So the course of hydrolysis is monitored by periodically testing with iodine solution. For acid hydrolysis of starch, we have to take 18 ml of the starch solution in a beaker and 9 drops of concentrated HCl is added to hydrolyze the solution. And this is kept in the boiling water bath, and from the first minute we are going to periodically test the hydrolysis of starch. Starch is converted to glucose. So before converting to glucose, it will form the various dextrins, amylodextrins, erythrodextrins, acrodextrins and finally only glucose. The various dextrins with iodine solution will give different colors. Now we will do the course of hydrolysis of starch. After 1 minute, 2 ml of the sample is taken, cooled well, and iodine test is done. So this is the soluble starch stage. So with the iodine solution, it gives an intense blue color. After cooling down, the soluble starch state is taken and iodine test is done. For the iodine test, we are taking this 2 ml of the sample and 2 drops of the sample. We can see the presence of blue color, but the solution is clear. After 5 minutes, 2 ml of the sample is taken to do the iodine test. This is cooled and we are going to add the iodine sample. Here we can see the purple color formation due to amylodextrins. First hydrolysis continues. Now we are taking the sample after 10 minutes. 2 ml of the sample is taken and we have to cool it and do the iodine test. Erythrodextrins form red color with iodine. This is completely hydrolyzed starch solution after complete hydrolysis of 1 hour. So now the starch has been converted everything to glucose. Now we are going to neutralize the solution and we are going to do the Benedict's test and the Selivanov's test to prove that starch is a homopolysaccharide of glucose. That is, it is a monosaccharide present in the starch is only glucose. Now we are going to do the Benedict's test. For Benedict's test, we are going to take 3 ml of the Benedict's reagent and 5 drops of the neutralized solution. 5 drops added and mixed well and kept in the boiling water bath for 2 minutes. After 2 minutes, we can see for the Benedict's test, the appearance of brick red color indicates the presence of reducing sugar, glucose. For Selivanov's test, 1 ml of Selivanov's reagent is added and 1 ml of the sugar solution is added. Selivanov's test is a test for keto sugar and this is kept in the boiling water bath for 1 minute. After 1 minute, we can see there is no change in the solution. That means if the keto sugar are present, we can see the formation of cherry red color solution. Glucose being the aldose sugar, there is not any color change. So this shows that starch is formed of the reducing sugar, glucose.
With the preliminary test, we conclude that starch is a polysaccharide and non-reducing carbohydrate. On hydrolysis with HCl, starch will finally form glucose The course of hydrolysis of starch is periodically tested with iodine solution, which shows formation of various textrines. Each textrines will form various colors. After complete hydrolysis, we conclude starch is formed of glucose, aldose sugar by doing Benedict's and Selenox test. Thank you.